I'm going to go through one example now of linear modeling, and I'm going to go through this in some detail. So I might suggest watch the video from start to finish. Okay, don't forward through any part of the video, because I'm going to go through each part in a little bit of detail. Okay, so this will be a really good study for you, at least to give you the basic idea of a fairly exhaustive example involving linear modeling. So the cost of catering for a birthday party is shown in the following table. Number of guests, N, is in the top row. So for 5 guests, for example, it's going to cost $350 for catering, and that's given, and we're going to use the pronumeral C, or capital C, to represent the cost of catering. 10 guests, okay, so when N is 10, the cost of catering is $550, so C would equal 550, and so on. So part 1, state the dependent variable. Okay. Part 2, determine the gradient of the linear relationship between N and C. Part 3, find the vertical intercept of this linear relationship. Part 4, write the equation of this linear relationship for C in terms of N. Okay. Part 5, we're going to graph the equation of the linear relationship found in part 4. Part 6, what does the vertical intercept of this function represent? Now, we've used this term, the vertical intercept, probably for the first time. I didn't use it in the last video, but vertical intercept is the same as the Y-intercept. The only reason why I can't say, or we can't say Y-intercept here, is because we're not using the variable Y, okay? So we're using something else to represent that. So we call it the vertical intercept. So if you're just wondering why I didn't call it the Y-intercept, or why it's not called that. Anyways, just moving on, part 7, find the cost to cater for 88 people. And part 8, $2,870 was spent on catering. Calculate how many guests attended the party. Okay, so it's a fairly standard example. I wouldn't say that there's any tricks to this at all. There really isn't any tricks to really any maths problem. It's just really a matter of making sure you understand what is going on and using the tools at hand to be able to answer this question. So let's go back now to the beginning. If you want to, you can pause the video and give this example a go for yourself before you look at the worked example, okay? In fact, I tend to do this with a lot of the videos. Just pause it at any time, give it a go, see if you can answer it, and then basically just skip through or skip throughout the video to the solution if you like. But I dare say, probably for the first time around, at least watching this video, listen out for the explanations, okay, and the rationale behind the solutions. All right, let's start. State the dependent variable, okay? Independent and dependent, okay? So the independent variable is like the X variable, and independent variables always use the top row, okay? They're the ones that we have some control over, okay? So this is the independent variable. The dependent variable, okay, the one where the dependent variable, the one that depends on the independent variable, where the value depends on whatever the independent one is, that's the bottom row, okay? So the dependent variable is the cost of catering, which is C, okay? So part 2, determine the gradient of the linear relationship between N and C. Now, this is no different to just using the gradient formula to find the gradient between 2 points. So in the previous videos, or the previous video that we looked at when we looked at the topic of the gradient formula, you can just pick any 2 points you like from the table, and you can use those 2 points to find the gradient using the gradient formula. So I'm just going to do the solution here on another board. Okay, so this is the solution for part 2. Okay, now I'm going to go between the 2 boards. So maybe I might just, sorry for the reflection of the light there. So maybe I might just do that if you can see that. Okay, so maybe just there will be fine. So, whoops. Okay. So using the gradient formula. Okay, so M is equal to, okay, y2 minus y1 over x2 minus x1. Okay, and we need to pick 2 values or 2 points from this table. And we can pick the first 2 points if you like, or we can pick the first point and the last point. Actually, it doesn't matter, all right? So why don't we just pick the first 2 points? Okay, so we're going to let x1, y1 be 5 and 350, and x2, y2 be 10 and 550, okay? So that's going to be equal to, okay, so y2 minus y1, so the y values, okay, is the bottom row, the dependent variable. Okay, so that's going to be 550 minus 350 over, okay, x2 minus x1. So this is the independent variable now. So this is the top row, 10 minus 5. Okay, let's work that out. Okay, so 500, and if you do it as a fraction, 550 minus 350 over 10 minus 5, and we get 40. Okay, so that equals 40. So I guess the question here is, what does this 40 represent? Now that wasn't actually asked basically in the question, but I'd like you to have a think about, what does this 40 represent? Okay, remember, a gradient is the rate of change, right? It's a rate of some kind. A rate comparing which 2 things? We're comparing a cost to the number of people. So this is a rate, okay, of the cost per person. Okay, so okay, while this is not part of the solution because you're not asked what this represents, I think it's just a nice side note there. Okay, so what does this represent? Every person we add, it's going to cost $40. Okay, add another person, another $40. Right, let's have a look at part 3 now. Okay, so part 3 says find the vertical intercept of this linear relationship. Okay, again, seems fairly familiar. We've done this in a previous example where there was no actual context. Okay, there was no background, it was just an abstract example. We're going to do the same thing here. The fact that it's about catering in a birthday party doesn't make a difference in the slightest. Okay, we're just going to use the values for what they are. The interpretation of those values, we'll worry about that later. But we do know that it is obviously corresponds to this real life situation. All right, so let's find the vertical intercept of this linear relationship. All right, now if you recall, okay, so this is part 3. Okay. We know that the formula is going to be in the form y equals mx plus c. Okay, but we're not going to use the variables y and x. Okay, so because this is a linear model of a real life relationship, the y is in fact really the capital C, isn't it? So that's the dollar amount, okay, that it's going to cost to the catering cost is equal to, now instead of using x, what does x represent in this example? The x represents the number of people. Okay, so it's going to be mn plus small c. Okay, so this is in fact the vertical intercept. Okay, or the y-intercept. All right. Okay, we do have an m now. We've found the m. Okay, and we do need a point to substitute in, to a point for C and C and N to be able to find the vertical intercept. All right. Now going back here. Okay, so $C, capital C, minus MN is equal to little c. Okay. Just be careful here to make the capital C. Make sure you make it fairly large so you can see the difference between a lowercase c and an uppercase c. It's very rare, or it's quite rare for this to come up, but if it does come up, make sure you differentiate between these two c's. They're different pronumerals. Okay, so uppercase and lowercase can mean totally different things in algebra. Right, let's pick a point. In fact, conveniently, because it's actually on the screen here, we've got 35 for n, gives us $1,550 for c. So let's substitute these points in. Okay, so 1550 minus, now m is 40, okay, so that's the gradient, times n, which is the number of people, so this is from this point here, 35, is equal to c. Okay, so little c is equal to, let's work this one out now, so 1550, okay, minus 40 times 35, and we get 150. Okay, so therefore the vertical intercept, right, is equal to 150. Now remember that the vertical axis represents money, dollars. So that's $150. So I want you to start thinking about, well, what could this mean? All right, what does the vertical intercept mean? So let's do part 4, okay, which is, and I'll just bring this back board here, which is write the equation of this linear relationship for C in terms of n. So this is in the form y equals mx plus c, but without using x and y. We're going to use the pronumerals that represent those. All right, so let's go back to that, to the solution. So part 4, it's going to be in this form here. So c equals mn plus little c. So let's do that. So c dollars, okay, is equal to, okay, now the m we have a value for, which is 40. So it's going to be 40n, okay, plus 150. Okay, so now we have an equation. N represents the number of people, so the number of guests. So whatever the value of n is, this is the independent variable. We substitute into the formula, and then we can get a dollar amount of catering costs then based on those number of people. All right, let's continue on and go to the next board. Okay, so that's these questions here. It says to graph the equation of the linear relationship found in part 4. So I'm just going to write that here, and I'm going to graph this using technology. Okay, so obviously in an exam situation, you're not going to use a graphing calculator. Okay, you're going to be graphing this manually. All right, so we just need to be mindful that the scale that you use is an appropriate scale. Okay, so again, with some graph paper, you would do that, and you would set the scale accordingly. All right. So I'm going to use some technology now to graph this. Okay. And I'm going to use a graphing calculator for this. Now, of course, you're not allowed to use these in an exam situation. All right. But I thought just for demonstrating the use of technology, and it is actually quite a useful little gadget, this one. Okay. If you want to do some visualization. All right. So I'm just going to reset that. Okay, so this is a graphing calculator. This is the Casio FX CG50, all right, which is a fairly current model of graphing calculator. And we're going to enter in the formula. Okay, C equals 40n plus 150, but we're going to use the variables x and y here to represent that. All right, so let's type that in. Okay, so I'm going to type it in as 40, okay, x plus 150, okay, and it's going to press equals there to enter that in. All right, now let's graph that. So if I press the draw button here, let's see what happens. All right, so I'm going to zoom out there, and there's the equation of our linear function. I might just zoom in a little bit there so you can see what's going on. Okay, and it might just, there we go, just zoom in a little bit there. All right. And yeah, so you can see that the y-intercept, okay, or the vertical intercept, because we're not really using the pronumeral y, okay, so that's that intercept there. That's at 150. In fact, I just want to show you something. What is the x value, or what is the independent variable's value at the y-intercept? Let's find out. Okay. Now we're going to use the solve function here. Okay, and we're going to calculate the x value. Okay, so we're going to enter in our y value. So this is going to be the y, or the vertical intercept. We calculated 150 if you recall. Okay, and there's our solution there. Okay, so x is in fact equal to 0, and that's in fact where the y-intercept occurs, or the vertical intercept occurs. It occurs when x is equal to 0. Okay, we get y is equal to 150. All right. Okay, so going back to our function, okay, we can in fact, there's a trace function on this calculator as well. So we can just sort of move around anywhere on this line, and that'll give us an x value here. So this is our n, if you remember, the number of people. Even though it's in decimal, we know it has to be a whole number. And the y value here gives us a cost as well. Okay, All right. So your graph should look something like this. I'm just going to get back out of this. Okay, so yeah. So your graph should look something like this. All right. So take note of the scale as well. Okay, so you might use a fairly small scale. In fact, or maybe probably squash the scale up a little bit more on the x-axis. And there's a scale that you could potentially use on the y-axis there. I probably wouldn't use this scale here. I'd probably go maybe 5, 10, 15, 20, 25, 30, 35 might be a bit more appropriate. But use whichever scale you deem or you see appropriate to show as much detail as possible. All right, so move that out of the way. Okay, and let's continue on. So this leads me now to part 6. What does the vertical intercept of this function represent? And I did ask that question before. We got 150, okay, if you remember. So, okay, where was it? Here we go. Okay, 150. What does it represent? X equals 0, but in this case we're using the letter n. N is the number of guests. 0 guests. So what do you think this means? So vertical intercept of the function could mean, or maybe in this particular situation, is like a minimum, absolute minimum charge. So even if you had no guests, okay, so I might just put the solution here. So this is what, okay, so what does the vertical intercept of this function represents? Okay, so the $150, okay, may a minimum charge. Okay, a minimum charge for catering. Okay. Before any guests are considered. Okay. It could even be a cover charge, for example, or a booking charge, or it could even be a delivery charge. It could be a setup cost. You know, it could be anything. So it doesn't matter what you say there, as long as it's justifiable, it's plausible, it makes sense. Okay, it's a reasonable response based on this situation given. You most likely, or more likely, you're going to get the mark. Okay, as long as it makes some sense. So I would say it's just the minimum charge for catering before any guests are considered. So even before it just, or could be a booking charge, whatever. Okay, as long as what you write there makes sense. All right, let's go to the next part here, which is find the cost now to cater for 88 people. All right, so 88 people. While I'm just setting this up. Okay, so for 88 people, n is equal to 88. Okay. And we also, I'm just going to write down the formula again. So C is equal to 40n plus 150. Okay, so n is equal to 88. N represents the number of people. All right, so that's going to be 40 times 88 plus 150. Okay, 40 times 88 plus 150, and we get $3,670. Okay, to cater for 88 people. And the last one, so V111, okay, part 8, $2,870, okay, was spent on catering. Calculate how many guests attended the party. Okay, so we're gonna have to rearrange this formula somehow. All right, so we've got a charge here of 2870. Okay, and that's equal to 40n plus 150. And we need to solve for n. We need to know what value of n that when we substitute it into the equation will give us a charge of $2,870. So we're going to need to rearrange this formula. So first thing I'm going to do is I'm going to subtract 150 from both sides. So this is where your skill of algebra and in particular equations will come in very useful. Okay, so 2,870 minus 150, when we move that over, we subtract 150, is equal to 40n. All right, so I might just do this a step at a time so you can see what's going on. So 2870 minus 150 is 2720. Okay, so 2720 is equal to 40n. Okay, then we're going to divide both sides by 40. And, well, you can move the 40 over, just put it underneath the 2720. So n is equal to 2720 over 40. Okay, so moving the 40 to the other side becomes a division, opposite of what it's currently doing there, which is multiplication. 2720 over 40, hope you can see that there, yep, that's better, is equal to 68. Okay, n is equal to 68. So therefore, 68 people were at the party. So I just squashed it up there. Alright, so just make a little conclusion there in plain English, 68 people were at the party. And that concludes this example.